Composites. Direction matters. Hello everybody, I am Nick the Naval Architect, and today I want to provide a brief demonstration of the directional nature of composite materials. Composite materials are orthotropic materials, meaning that they have different strength properties depending on whether or not you're providing stresses in the fiber direction or transverse direction. As a result, direction matters. We have to be very careful to make sure that we align our composites to keep the strawn edge aligned with the stress directions. There's another side effect of composites that people don't always realize. Because they have such a strong orthotropic nature, if you use the wrong direction, you can actually force stresses to follow a different path than they normally would prefer to. That creates much higher stress concentrations, requires much higher material thicknesses, and is all around a bad design. Let me show you an example. So here we have a simple diagrammed layout of a ship. One of the primary concerns for ships is stresses in the longitudinal direction, running along the length of the ship. If we were to put composite material on the deck of the ship, we might think about taking some unidirectional fibers and running it lengthwise. Now that sounds well and good, except we have the problem that there are also stresses running in the transverse direction, and this unidirectional won't do anything for that. So let's get rid of that. Let's instead put in a piece of cloth. This would be a 090 fabric where we have fibers running in the direction of 0 degrees and 90 degrees. Now we have our composite oriented for both the longitudinal direction and the transverse direction. What would this look like if we did it wrong? Well, if we ran our fibers at 45-degree angles instead, that's going to force the stresses to take the wrong load path. The stresses want to run straight along, but instead, we're going to force them to start at this side, cross all the way over, come back all the way over here. That is not an optimal load path. I am exaggerating for demonstration purposes here. In reality, you would have a fabric laid out like this, and then the stresses wouldn't have to go all the way across the ship. They would just have to go until the next part of the fabric. However, this is still forcing the stresses to take a non-optimal load path. That's going to mean bad design, more material, more stress concentrations. Of course, we do have a problem here. There are stresses also running in the plus and minus 45-degree direction on the hull. That's due to hull torsion. So shoot, now we need multiple fabrics. So we might put some unidirectional here, and then we might also put some plus or minus 45, and then we might put some 090 underneath it, and I have run out of sticks to demonstrate this. This is why you see composites with layups of multiple layers and fabrics oriented in different directions. They're trying to keep strength for different sets of stresses in the hull, and trying to account for multiple situations. Because when composites are done right, you get good, strong fibers for very little weight. When composites are done wrong, you get fracture. Thanks very much. I am Nick, the Naval Architect. I've got a secret for you. Anytime you see me showing something on video, I have services available that are way better than what you see for free. So check out the website to find out how I can make your next project easier.